Hi, hello my dear students, a very good evening to all of you. Warm welcome to Turito live classes. So, yesterday we have started real numbers. In real numbers we have discussed some concepts. So, what are the numbers and properties of numbers, and we have done some problems. Okay. So, tomorrow we are going to discuss some more concepts in the chapter real numbers. So, first let us recap. So, what we have discussed in the last class. So, in today's class we are going to discuss properties and representing of real numbers on the number line. But in the last class what we have discussed, that is recap. Recap means what we have discussed in the last class. Introduction to numbers. So, we have discussed about natural numbers, whole numbers, real numbers, rational numbers, irrational numbers, like that. So, that is introduction to numbers. Next, in introduction to numbers, what we have discussed? Natural numbers, whole numbers, integers, rational numbers. After that, we have discussed also properties of numbers, and after that we have discussed some problems related to those concepts. So, in today's class what we are going to discuss in the chapter real numbers. So, in today's class we are going to discuss how to represent the real number on the number line. In the last class we have discussed what is the real number, the combination of rational and irrational numbers. The combination of rational and irrational numbers is known as a real number. A rational number means any number of the form p by q. Okay. A number which cannot be expressed in the form of p by q is known as an irrational number. So, the combination of rational and irrational numbers is known as real numbers. So, how can we represent one real number on the number line? In our previous classes we have discussed about the number line. Next, properties of real numbers. According to real numbers we have some properties, we can discuss those properties also. Representing real numbers on the number line. Okay. How can we represent one real number on the number line? Here let us take one example. I can explain this part by taking one example. So, follow step by step, you can easily understand. So, look at 3.895 on the number line. So, for your understanding purpose I have taken one real number as 3.895. It is not necessary to consider that number only, you may consider the real number as your wish. So, whatever the real number may be. So, how can we express that number on the real number line? So, let us take the solution of this part. So, we can find the solution. So, we can denote the given real number 3.895 on the real number line. So, by proceeding the following steps. Step 1. So, by observing the number 3.895, by observing the number 3.895, everyone can say that number lies between 3 and 4 on the real number line. 3.895, that is a real number, and we know that number lies between 3 and 4. So, 3.895 lies between 3 and 4. We divide this into 10 equal divisors and mark them as 3.1, 3.2, 3.3, 3.4, so on, as shown in figure 2 given. So, once look at this figure. So, this is the real number line. On this real number line we know all the numbers right side of 0 are positive real numbers, left side of 0 are negative real numbers. So, what we have to locate? We have to locate the real number 3.895 on this number line. So, first take the real number line like this. So, from this real number line you can take the two numbers 3 and 4 like this. Just look at the figure 2. So, this is figure 1, this is figure 2. So, 3.895 lies between 3 and 4. we divide this into 10 equal divisions and mark them as 3.1, 3.2, 3.3 and so on as shown in the figure given. So, this is 3, this is 4, this is 3, this is 4. Between 3 and 4, we have divided the part between 3 and 4 again as 10 equal parts and we have taken them as 3.1, 3.2, 3.3, so on 3.9. So, this is 3 and this is 4. Next, this is step 1. After that, in step 2, if you look at this part of the number line closely as through a lens, it would appear as shown in figure 3. So, this is figure 1, figure 2 and this is figure 3. If you look at this part of the number line closely as through a lens, it would appear as shown in figure 3. So, by observing this is figure 3, we divide this into 10 equal divisions and label them as 3.81, 3.82, 3.83, so on. So, look at the figure 3. So, this is real number line, this is 3, this is 4. Between 3 and 4, we have taken 3.1, 3.2, so on like this, that is figure 2. So, again from 3.8 to 3.9, you can divide that as 3.81, 3.82, 3.83, so on 3.9, 3.9. That is step 2. If you look at this part of the number line closely as through lens. So, this circle represents the lens. It would appear as shown in figure 3. We divide this into 10 equal divisions as 3.81, 3.82, 3.83, so on 3.89, 3.10, then you will get the figure 3. Next, step 3. 3.895 lies between 3.89 and 3.9. Okay. Again, you can use the lens. So, this is 1, 2, 3 and this is fourth one. 3.895 lies between 3.89 and 3.9. If you look at this part of the number line closely, it would appear as shown in figure 4. So, this is figure 4. So, this is the real number line. This is 3, this is 4. We have divided this between 3 and 4. We have divided the part between 3 and 4 as 10 equal parts, 3.1, 3.2, so on 3.9. Next, you can take 3.8 and 3.9. Between these two numbers, again we can divide the part into 10 equal parts as 3.81, 3.82, so on 3.89, 3.9. Okay. So, from this, so between 3.88 and 3.9. So, here 3.895 lies between 3.89 and 3.9. So, this is 3.89, this is 3.9. So, clearly the number 3.895 lies between 3.89 and 3.9. If you look at this part of the number line closely, it would appear as shown in figure 4. So, this is figure 4. We divide this into 10 equal divisions and label them as 3.891, 3.892, 3.893, 3.894 and so on. Mark 3.895 as P. Okay. Again, you can take the number 3.89 and 3.9. So, between these two numbers, we can divide the part again into 10 equal parts and we can name them as 3.891, 3.892, 3.893, so on 3.899. So, what we have to represent? So, we have to represent 3.895 on the real number line. So, we divide this into 10 equal divisions and label them as 3.891, 3.892, so on. Mark 3.895 as some P. P means that is point. So, clearly point P on the number line represent 3.895. So, these type of problems are important for long answer questions in final exams. Okay. So, just by taking the number 3.895 I have explained how to represent that number on the real number line. So, just like that you can take any number. So, for example, if you take 10.261, so you can take this as practice. Represent the number 10.261 on the real number line. Means you have to take two numbers 10 and 11. According to that, you can represent the number 10.261 on the real number line. Similarly, you can take represent the number 6.535 on the real number line. Okay. So, you can take these two as practice, and you can whatever the real number line, whatever the real number may be, we can represent that real number on the real number line like this. So, hope you understood. So, if you are not able to understood, so then you can take the recorded session and try to understand. Okay. Next. Now, let us discuss properties of real numbers. So, some properties are there sorry, regarding to real numbers, we can discuss them. So, first one, addition property of real numbers. Addition is nothing but sum. When two numbers are there, we have to add those two numbers, but here the two numbers must be real numbers. So, first let us take closure property. Closure property. What is the meaning of closure property? The sum of two real numbers is always a real number. The sum of two real numbers is always a real number. You may add any two real numbers. What is the meaning of real number? That is the combination of rational numbers and irrational numbers. So, that is why you can consider any two real numbers and you can add them. By adding them, you will get another real number. That is that number is also, you will get one number, that number is also a real number. So, for example, if we take 2 plus 3, clearly we know 2 and 3 are real numbers. By adding them, you will get 2 plus 3 equal to 5, that is also a real number. It is not necessary to take the integers. If you want, you can take 1 by 2 plus 1 by 3. So, actually these are rational numbers because they are in the form of p by q. So, by adding these two numbers, so by taking the LCM of 2 and 3, you will get 6. 2 3 is 6, 3 1 is 3 plus 3 2 is 6, 2 1 is 2. So, 3 plus 2 5 by 6. 5 by 6 is also a rational number. 5 by 6 is also a rational number because that is in the form of p by q. But we know every rational number is a real number. It is not necessary to consider the positive numbers only. You may consider negative numbers. So, for example, if you take minus 3 by 4 minus 2. Here we have both negative numbers. Minus 3 by 4 is negative number, minus 2 is also negative number. So, by simplifying 4 into minus 2 minus 8, minus 3 minus 8 by 4, you will get minus 11 by 4. So, it is also a real number. So, this property is known as closure property. The sum of two real numbers is always a real number. Okay. Sorry. Next, associative property. So, associative property means if A, B, C are three real numbers, then A plus B plus C equal to A plus B plus C. Okay. If A, B, C are any three real numbers, okay, you may take any three numbers A, B, C, then by observing this, where LHS part is A plus B plus C and RHS is A plus B plus C. So, for any three real numbers A, B, C, if LHS equal to RHS, then we can say that is associative property. So, for example, if we take A equal to 2, B equal to 3, C equal to 8. Sir, why are you taking those numbers? I want to take different. Your wish. Just I told you, you may take A, B, C as your wish. You may take integers or you may take real numbers, or you may take irrational numbers, whatever it may be. Okay. So, if A, B, C are any 3 real numbers, here if we take LHS part, what we have? A plus B plus C, A plus B plus C. A plus B means 2 plus 3, 5 plus C, 8, 5 plus 8 equal to 13. Next, if you take A plus B plus C, that is RHS, A plus B plus C equal to, A plus means 2 plus B plus C, 3 plus 8, 11. By adding these two, we got 13. By observing, we can say these two are same. So, for the 3 real numbers, A equal to 2, B equal to 3, C equal to 8, we got A plus B plus C equal to A plus B plus C. So, you may take any 3 real numbers, you may take integers or rational numbers or irrational numbers, whatever it may be. So, for every 3 real numbers A, B, C, it is true A plus B plus C equal to A plus B plus C. This property is known as associative property. Next, commutative property. So, what is commutative property? If we suppose that A and B are 2 real numbers. So, add A and B means A plus B, add B and A means B plus A. So, by finding A plus B and B plus A, those two should be equal, A plus B equal to B plus A. Commutative property means if A and B are any 2 real numbers. For associative property, we have considered 3 real numbers A, B, C. For commutative property, you have to consider only 2 real numbers. If those 2 real numbers are A and B, then A plus B equal to B plus A. So, for example, if we take A equal to 1 by 2, B equal to 3 by 4. So, you can take as your wish. You can take as your wish. Here, if you take LHS, that is A plus B. What is A? 1 by 2. What is B? 3 by 4. Now, what is the LCM of 2 and 4? Clearly, that is 4. 2 times 2 1 ja 2. 4 1 ja 4. 1 into 3 3. 2 plus 3 5 by 4. That is A plus B. Similarly, if we take RHS, B plus A equal to, what is B? 3 by 4. What is A? 1 by 2. So, for 4 and 2, by taking 4 as LCM, 4 1 ja 4, 1 into 3 3, 2 2 ja 4, 2 1 ja 2. So, 3 plus 2 5, denominator 4. By observing, where A plus B equal to 5 by 4, B plus A is also 5 by 4. That is why we can say A plus B equal to B plus A. So, that is why we can say A equal to 1 by 2 and B equal to 3 by 4. These two real numbers are following commutative property. So, I am giving you two numbers A and B. So, once you can check whether they are following commutative property or not. A equal to 10, B equal to 15. So, what is your answer? So, can you check whether they follow the commutative property or not? Yes, very good. My answer is correct. So, A plus B means 10 plus 15, 25. 15 plus 10, 25. So, by doing A plus B and B plus A, we are getting the same value 25. So, that is why we can say 10 and 15 are following the commutative property. So, if you take the negative numbers, A equal to minus 2 by 3 and B equal to 5. So, once you can check and you can post your answer in the chat box. So, A equal to minus 2 by 3 and B equal to 5 are given. So, what is your answer? Whether they follow commutative property or not. So, yeah, once check your answer. Yes, very good. So, these two numbers follow the commutative property, minus 2 by 3 plus 5, and you can do 5 plus minus 2 by 3. In both cases after simplification you will get the same value. So that is why we can say these two numbers follow the commutative property. Next, existence of additive identity. If you suppose that a is any real number, if there exists another real number 0 such that a plus 0 equal to 0 plus a equal to a plus 0 equal to 0 plus a equal to a, then 0 is called the additive identity of a. Very simple. So we have to add some number to the given number to get the same number. It is possible only when 0 is added to the given number. Okay. For example, 10 is there. 10 is there. We have to add some number to 10. After simplification, again you have to get 10. When is it possible? Just by adding 0 only. Why 10 plus 0 or 0 plus 10 equal to 10? In this case, this 0 is called the additive identity. Let a be a real number. If there exists a real number 0 such that a plus 0 equal to 0 plus a equal to a, then 0 is called the additive identity of a, whatever the real number may be. So for example, if we take 5, so if I ask you what is the additive identity of 5, simply you can say that is 0. Why? 5 plus 0 or 0 plus 5 both are equal to 5. So by adding 0 to 5 we are getting again 5. That's why we can say 0 is the additive identity. Can you say what is the additive identity of minus 1 by 10? So you can send your answer in the chat box. No? What is the additive identity of minus 1 by 10? Yes, very good. So 0 only. Whatever the real number may be, that may be rational number or irrational number, whatever it may be. So for any real number we can say 0 is the additive identity. If I give you 99, if I ask you what is the additive identity of 99, simply you can say 0. Whatever the real number may be, for any real number we can say the additive identity is 0 only. Next. So properties of real numbers. Next, addition of properties of real numbers. So existence of additive inverse. So the continuation, already we have discussed some properties in the previous slide. This is another property with respect to the addition. Existence of additive inverse. Let a be a real number. If there exists another real number b such that a plus b equal to b plus a equal to 0, then b is called the additive inverse of a and is denoted by minus a. So additive identity means 0, just we have discussed. Additive inverse means we have to add some number to the given number. We have to add some number to the given number to get 0. So then the adding number is known as additive inverse. So here if you suppose that a equal to 15, here we have to add some number to a to get 0. When it is possible? Only by adding minus 15. So that's why if we take b equal to minus 15. Now if we take a plus b, 15 plus minus 15 plus into minus minus, you will get 0. Similarly b plus a, b equal to minus 15 plus a, again you will get 0. So by taking a equal to 15 we can say the additive inverse of this 15 is minus 15. Very simple. Just you can change the sign of the given number. If plus is there, take minus. If minus is there, take plus. So what is the additive inverse of a equal to 2 by 7? What is your answer? If a equal to 2 by 7 is the given real number, then what is the additive inverse? Very simple. 2 by 7 is there. Don't change the numerical, just you can change the sign only. So b equal to minus 2 by 7. If a equal 2 by 7 is the given real number, then minus 2 by 7 is the additive inverse of 2 by 7. Very easy, just you can change the sign of the given number. So, if we have minus 12, what is the additive inverse of minus 12? Can you send your answer? I have given minus 12. What is the additive inverse of minus 12? Yes, very good. That is plus 12. Plus 12. So, minus 12 is there, just you can change the sign. Since minus is there, take plus. So, plus 12 is the additive inverse of minus 12. So, similarly we can say the additive inverse of B is minus B, the additive inverse of A is minus A, the additive inverse of B is minus B, the additive inverse of X is minus X, the additive inverse of K is minus K, like that. So, just I told you, just you can change the sign only. If plus is there, take minus. If minus is there, take plus. Next. So, multiplication properties of real numbers. So, just we have discussed addition properties of real numbers. Addition means sum. Now, let us discuss multiplication properties of real numbers. Multiplication properties mean into. Multiplication means product. So, first let us take closure property. The product of two real numbers is always a real number. You may take the product between the two real numbers. So, for example, if you suppose that the first number is 5, the second number is minus 3. You may take the two real numbers as your wish, there is no restriction. Multiply them, what will you get? 5 into minus 3 equal to minus 15. Clearly, minus 15 is also a real number. If you suppose that the first real number is 1 by 2, second real number is 2, multiply them, 1 by 2 into 2 to get cancelled, we got 1, 1 is also a real number. You may take positive real numbers or negative real numbers, or one is positive, one is negative. If you suppose that first one is minus 2 by 7 and second one is minus 7 by 2. Now, by finding the product of these two real numbers, minus 2 by 7 into minus 7 by 2. 7 7 get cancelled, 2 2 get cancelled, minus into minus plus 1. So, this is also a real number. So, the product of two real numbers is always a real number. Next, associative property. If A, B, C are any three real numbers, then A into B into C equal to A into B C. So, just like addition, for addition we have added the real numbers. With respect to multiplication, we have to multiply the given numbers. You may take the three real numbers A, B, C as your wish. If you suppose that A equal to 3, B equal to 5, C equal to 10. So, where you taking those numbers? I want to take different means your wish. Already I told you, you can take the three real numbers as your wish. There is no restriction. Now, here take LHS part. AB into C. AB means A into B into C, where AB means 3 into 5, 15 into C, 10. 15 into 10 equal to 150. Next, if we take RHS, A into BC, where A equal to 3, BC means B into C, 5 into 10, 50, 3 into 50, 150. So, by observing these two, AB into C is 150, A into BC is also 150. That is why we can say the numbers AB into C equal to A into BC. The number 3, 5, 10 are following the associative property. Next, commutative property. So, commutative property means you can suppose any two real numbers A and B. Multiply A and B, you will get AB. Multiply B and A, you will get BA. If those two are equal, then we can say the two numbers follow the commutative property. So, for example, if we suppose that A equal to, So, if you suppose that A equal to minus 3, B equal to plus 2. Okay. Now, what we have here, AB means A into B means minus 3 into 2 minus 6. Next, RHS is BA. What is BA? 2 into minus 3 equal to minus 6. So, clearly we can say A into B equal to B into A. That is why with respect to the multiplication we can say the two numbers minus 3 and 2 are following the commutative property. Next, existence of multiplicative identity. Okay. So, existence of multiplicative identity. If you suppose that A is a real number, if there exists a real number 1 such that A into 1 equal to 1 into A equal to A, then 1 is called the multiplicative identity of A. So, we have to multiply the given number by another number to get the same number. It is possible only when the given number is multiplied by 1 only. Then we can say that 1 is the multiplicative identity. So, for example, if we have A equal to 25, if you multiply 25 by 1, so A into 1 equal to 25 into 1 equal to 25. So, or you may take 1 into A, 1 into 25 equal to 25. So, this 1 is known as multiplicative identity. So, multiplicative identity means we have to multiply the given number by another number to get the same number. It is possible only when the multiplied number is 1 only, whatever the real number may be. So, if we take minus 15, if I ask you what is the multiplicative identity of minus 15, you can say that is 1 only. Why? Minus 15 into 1 or 1 into minus 15, in both cases you will get minus 15 only. That is why we can say this 1 is the multiplicative identity. Whatever the real number may be, 1 is known as multiplicative identity of the given real number. Next, existence of multiplicative inverse. If you suppose that A is a real number, if there exists another real number B such that A into B equal to B into A equal to 1, then B is called the multiplicative inverse of A and is denoted by 1 by A, and is denoted by 1 by A. So, multiplicative identity means we have to multiply the given number by another number to get 1. So, it is possible only when the given number is multiplied by the reciprocal of it. So, means if we suppose that A equal to 5, we have to multiply 5 by another number to get 1, means we have to take B equal to 1 by 5, B equal to 1 by 5. Now, let us do A into B equal to 5 into 1 by 5, 5 get cancel 1, or you may take B into A equal to 1 by 5 into 5 equal to 1. So, here this 1 by 5 is known as multiplicative identity of 5. Just you can take the reciprocal, very simple, very simple. If they ask what is the multiplicative identity of the given number, just you can take the reciprocal. So, if we take A equal to 28, then can you say what is the multiplicative identity of 28? What is your answer? Yes, very good. 1 by 28. Just you can take the reciprocal of 28, 1 by 28. If minus 100 is there, what is the reciprocal of minus 100? Very simple, you can take minus 1 by 100. Just you can take the reciprocal of the given number. Here we have one note, the multiplicative inverse of B is 1 by B. So, multiplicative inverse of A is 1 by A, multiplicative inverse of B is 1 by B. Next, distributive laws of multiplication over addition of real numbers. So, if you suppose that A, B, C are 3 real numbers, then A into B plus C equal to AB plus AC, that is known as left distributive law. So, here by observing B plus C means we are adding the numbers B and C. After getting the sum, we are multiplying that by A. So, RHS is A into B, A into C. Here we are multiplying B plus C by A from the left side. That is why we are calling that is left distributive law. Similarly, A plus B into C equal to A into C plus B into C. Here we are multiplying A plus B by C from the right side. That is why we can say this is the right distributive law. So, just you can take any two numbers. So, for example, if you take A equal to 2, B equal to 3, C equal to 4. You may consider any 3 real numbers A, B, C. So, take A into B plus C. A into B plus C. What is A? 2. What is B plus C? 3 plus 4, 7. 2 into 7 equal to 14. Next, if you take RHS, AB plus AC. AB plus AC. AB means 2 into 3, 6. AC means 2 into 4, 8. 6 plus 8 equal to 14. Where LHS is A into B plus C. RHS is AB plus AC. In both cases, we got the same. So, that is why we can say A into B plus C equal to AB plus AC. Similarly, you can check the right distributive law in place of A by writing 2, in place of B by writing 3. After that, you can multiply by 4 and you can do RHS AC plus BC. In this case also, you will get both LHS and RHS are equal. So, these two properties are known as distributive laws or distributive properties of multiplication over addition. So, if A and B are two real numbers, then root A into B equal to root A into root B. So, A and B are two real numbers. So, for example, if you have A equal to 2 and B equal to 3. So, we can write this as by separating root 2 into root 3. If A and B are two real numbers, then we can express that as square root of AB equal to square root of A into square root of B. Next, similarly, if we have the division like this, root A by B equal to root A by root B. So, for example, if we have square root of 2 by 3, if you have square root of 2 by 3, by separating the numerator and denominator, you will get square root of 2 by square root of 3. Next, we can do some problems related to the concept which we have discussed so far. So, in today's class, we have discussed addition properties of real numbers and multiplication properties of real numbers. Now, problem number 1, add 3 root 2 plus 7 root 3 and root 2 minus 5 root 3. Sorry, here we have two real numbers. First one is 3 root 2 plus 7 root 3. Second one is root 2 minus 5 root 3. We have to add these two real numbers. Adding is nothing but we have to take the plus sign between the given two real numbers. 3 root 2 plus 7 root 3 plus root 2 minus 5 root 3. Okay. So, by observing here we have irrational numbers because root 2 and root 3 are irrational numbers. So, by writing similar numbers at one place, root 2, 3 root 2 and root 2 are similar numbers. 7 root 3 and 5 root 3 are similar numbers. So, by writing similar numbers at one place, 3 root 2 plus root 2 plus the remaining two numbers are 7 root 3 minus 5 root 3. 7 root 3 minus 5 root 3, where 3 root 2 plus root 2. So, they are similar numbers. So, 3 plus 1 4, 3 root 2 plus root 2 can be written as 4 root 2. Like 7 root 3 minus 5 root 3. So, where root 3 is common, root 3 is common. So, that is why By subtracting 5 from 7, then what will you get? 7 minus 5 to root 3. So, this is the addition of the given two numbers 3 root 2 plus 7 root 3 and root 2 minus 5 root 3. Next one, multiply 5 root 11 by 3 root 11. Multiplication is nothing but into. So, take the first number 5 root 11 into second number is 3 root 11. So, clearly we can say they are similar numbers because root 11 is common. So, by taking the numbers 5 and 3, so here we can write 5 and 3 are rational numbers, but root 11 is an irrational number. So, root 11 into root 11 into root 11. So, 5 into 3 is 15, root 11 into root 11 is 11. 5 into 3 is 15, root 11 into root 11 is 11. So, root 11 means power 1 by 2, 11 power 1 by 2 into 11 power 1 by 2. By simplifying that, you will get 11. So, by multiplying 15 and 11, you will get 11 5s are 55, 11 1s are 11 plus 5 16. So, this is the product of the given two real numbers 5 root 11 and 3 root 11. Next, divide 15 root 15 by 3 root 5. Divide 15 root 15 by 3 root 5 means 15 root 15 divided by 3 into root 5. So, that equal to 15 root 15. So, this is 15. So, 15 root 15 minus 3 root 5. So, division means we have to take 15 root 15 in the numerator and in the denominator we can write 3 into root 5. So, just I told you, root a into b equal to root a into root b. Root a into b equal to root a into root b. According to that, where 15 can be written as 5 into 3. 15 into root 5 into 3 by 3 into root 5. 15 into root 15 can be written as 5 into 3 and denominator is 3 root 5. So, according to root a b equal to root a into root b formula, we can separate 15 into root 5 into root 3 by 3 into root 5. Okay. Here we can cancel root 5 and root 5 and 15 is cancelled by 3 5 times. Now, the remaining part is 5 into root 3, 5 root 3. So, by dividing 15 root 15 by 3 root 5, so we got 5 into root 3. So, 15 root 15 divided by 3 root 5. So, take 15 into root 15 by 3 root 5, write 15 as 5 into 3. So, by writing 15 as 5 into 3, we can take a equal to 5 and b equal to 3. So, root 5 into root 3. So, root 5 into root 3 by root 5. So, we can cancel root 5 and root 5, 3 5 times cancel. The remaining part is 5 into root 3. By dividing the first number by the second number, we got 5 root 3. So, these are some problems related to the concepts which we have discussed in today's class, and we are going to discuss some more concepts related to real numbers in the next class. So, thank you all my dear students for subscribing to Turito. Thank you very much. Have a nice day. Bye. Thank you all.